Okay, welcome to week 8 of Introduction to Programming, 1351. Were there any questions? Anything anybody had any hiccups with or wanted to go over about last week's talking points, which were rack configuration, card configuration, anything like that? Any issues with there was a lab last week?
So my only issue was when you're doing the adding the backplane one, I was having issues with the what was it? Adding the control module, like the extra Ethernet one
Okay.
from the lab. It didn't. What came up on my screen didn't match what was in the Word document. So that was kind of throwing me for a loop. So I wasn't quite sure what happened there, but
So
unless I download the wrong program, maybe.
I'm not sure. I can take a look.
Okay.
So the so when you add a new comms module, let me pull up that rack configuration.
Yeah, there's the 1756-CNB, I think.
CNB.
Yes.
So that's a yeah. I'm just going through the input card. CNBE.
It's the very start of part 4.
Yeah.
That's
Control net bridge. Ooh, they threw one at you, did they? So
And some of the quests for the revisions didn't work.
yeah. Okay, so it wasn't just me.
It was asking for like revision 31 when it said 15 is the max.
So we add this one into the base rack. And then we want to add another one. Close here. Sorry if you
Nice.
guys heard. It's one of the guys on the street got his dirt bike out. It's that time of year. Okay, so control net. So we add the card. Close. I'll open this up. So the chassis size, this in the change that it wasn't letting you change that. Is that
Well,
was that
I was having an issue with the revision number because it wouldn't go up to whatever it's at, like 31, and there's a couple other of them that didn't change, but I was also
in
just
here?
having issues.
Oh, in here? Okay, so
Yeah, where it's like 11.031 or wherever it was.
okay, that's frustrating that they would have done that.
It still worked if you caught it though, even without the revision.
Yes, so the revision number, firmware revision number. Yeah, so this is firmware 20.04. Place it in slot 0 for adding a new controller on the other one. Sorry, I'm just reading through the. Says to put it into slot 2 on the remote one. Controller into slot 2. So this revision So if you remember how I was talking about EDS files, um, and other stuff you may need to download to have access to data formats and firmwares, if your computer doesn't have the firmware pack inside its directory, you can't add it. So my guess is if it's telling you to use a higher firmware for this card, is that what it's telling you that it was wanted?
Parts 3 said to add the 3 remaining modules, which were revisions 3.16, 1.08, and 1.31. And the revision said you can only go up to 0.15, or when you try to do it here. So if you
Oh,
try to
sorry,
add
I was in part
16, it doesn't
4.
work.
I was
Yeah, I
in
think
part.
part 4 doesn't have the revisions above 15, so
Oh,
that
yeah.
should work.
So okay, sorry, I misheard you. So it says a new module for slot 11 is OB16D to slot. Mm. See if mine even has them. Yeah. So this is an issue with the firmware there. So 16, and then here it won't let you go to 16.
Yeah, once you press OK, it'll say it's not supported or something.
Hmm. Yeah, that's likely it's something to do with the files on this computer. Because I've never seen that issue. So again, you need to have the firmware for those cards. Those files have to exist in some sort of directory, to be able to actually access them. So a good quick way to check that. My software is kind of freezing on me. Hold on a sec. Is we went through this control. So control flash is not installed. What? Jesus. And where the heck is it? Really? This is really frustrating. There's so much software on these. It's good software, but there's so much that searching through it becomes a pain in the butt. My goodness. Isn't that in? It is nowhere to be found. Geologic. If anybody sees control flash, I am sharing my screen, right?
Yeah, just haven't seen it.
Doesn't make any sense. Why I can't control net shortcuts? No. Boot B utility. Control flash. The flash. Not what I want. No. Does everybody remember the control flash lesson we went through where I flashed the processor firmware on the processor I have here? Maybe not. Anyways, that's the same software that you would use to flash IO cards. So if you're trying to figure out if you have firmware versions for different cards, a really quick way would be to launch that software, navigate to your different cards, and then see if you can change the firmware if you've got something different. Because that software will automatically kind of populate. I'm trying to load it over here to show you guys. Should automatically populate if you can't get the revision that you're looking for that might be on the card. Because I have run into an instance where when you go into RS links here, and you might be able to see a specific card populate your RS links network tree, but then not be able to add that card and that firmware version to your program because you might not have that firmware version loaded in your directory. And it's just a matter of downloading those files from Rockwell. That's taking forever. I'll try to circle back to that. Again, and then if you don't have firmware, if you don't have the proper firmware files on your computer, normally you only need to make the major firmware version match anyway. So if you've got a revision 10 card and you set that to revision 10, that should work. Especially if you put in compatibility mode, major revision matching is enough. If you need an exact match for whatever reason, then the minor revision would have to match. But if you don't care, you could click disable keying and move on. And then it doesn't matter what the revision of that card is, the process will run. Is that control flash? Yeah, what the heck? This. So it's just called control flash, like I thought. So here's a, let's say you needed to reflash 32 point input card. You just launch it, navigate to one of them. I think that was the wrong one for me to try because I don't have one of those cards here. What do I have? I have an IB16I. So let's go back. IB16I. There, I have none, so I can't reflash this anyway. So whatever's default will have to work for me. Interesting that I don't have any. Makes me question what I believed and what I was telling you. I'm sorry about that. Might have caused more questions than answers there. I'm sorry if I just confused you more. I'm gonna have to look into that and why 13 didn't work. Any other questions that I can think I'm answering and then not actually know?
Was that lab to be submitted?
I think so. I think it's a graded lab.
Where would you want it submitted? Because I didn't find a submission point.
Well, let me take a look. Maybe it's not submitted. What lab did it say it was? Lab 4? It's not on the course list to submit the lab.
It just says week 7. It doesn't actually say what lab it is.
Well, that's fun. Doesn't look like it.
Yeah, I think last week there was no lab that was due.
There was
I think
a
there's a lab.
lab to work on, but yeah, there's no.
Yeah,
Doesn't look like there's any marks associated with it.
there is a lab due next week. That's for sure.
There's a quiz for next week,
Yeah,
and then there's a lab next week.
yeah, for the week after. Yeah.
Let me week 7. Yeah, there's no submission box for that. So, no. Just looks like just the quiz for last week. All right, anything else we can work on this week? Okay. So, up until now, we've been focusing on instructions that have used binary data, timers, kind of timers and counters that have their own data structures. So one of the next thing we're going to move on to, we're going to touch on tag naming structure for kind of some limitations and how the tagging in the controller tags will work. We're then going to start discussing some slightly more advanced binary operations, one shots, and then we're going to get into kind of some computational functions that the PLC can do. So some of your basic ladder logic ones, and then I'll show you some compute blocks. And then if you have any specific questions about ones that you might have seen used elsewhere, we can go over those. That's what we're going to cover today. So we've been playing with creating tags in a couple of different ways. So you can create them either inside your controller tag environment by typing in new tag and select your data type. So whether it's a dint, whether it's a bool or a real, but there's a few limitations to what can be accepted here, which aren't deal breaking in any way, but they can be a huge pain in the butt if you just don't know the rules. So this will accept special characters, underscores. Sorry, it'll do underscores and spaces, but the spaces will show up as underscores. You can't end a tag with an underscore. It'll tell you that here. So if you're going to use an underscore, you'll have to make sure, well, double underscores no good. That you follow the underscore up with something. You cannot begin a tag with numbers. It's just invalid. It has to start with a letter, or for some reason, you can start a tag with an underscore. Not really sure why the underscore can start a tag, but not end a tag. But that's just one of the limitations of the software. When you're using this, either the controller tag section or the program tag section, it's pretty obvious when you kind of get kicked out. It'll tell you right away that you can't create the tag that way. And then I said special characters, but it won't. It won't actually accept any of the shift special characters. So the only one is the underscore. If you are inside of a rung, and let's say you wanted to create a tag, we'll use a move command here, and we want to move special into a very special tag. It allows you to enter the space here, but when you right click, it's actually only going to see the words without before the space. Special, very special, it only will create very, and this will never recognize that second word. If you add in the underscore, now we can create a very special tag as whatever data point we want. But if you try to add in a space here, it will accept it. But you can't then create the tag with that special one. Edit special. Sorry. Did they fix that? I'm sorry. This might have just blown my mind. Wow, they fixed that. So you can create the second word as its own tag. That used to not work. So let me correct what I just told you. If you put the space in there, it will want to create two different tags. For this instruction, that's no good, but you can use math syntax in some of these text boxes on specific instructions. So you can string tags together in these boxes. So if you're in your ladder logic editing environment and you accidentally put spaces in and then try to create tags instead of using the underscores, you could create tags that you're not intending to create. It's not going to ruin anything, but it really might set you back a bit if you don't notice that you've got the space in there. Because if you were to right click and create only the very, and then further on try to use very special, it won't work. It won't be a recognized tag. And then you might have code execution issues because you've got some invalid tags. That makes sense, everyone? Very straightforward. Really, the take home there is if you make a tag, if you try to make the tag in the controller tags, it'll tell you right away if it's invalid. Making the tags in the logic is a bit of a mess if you don't pay careful attention to what's going on. Okay. So has anybody worked with one-shots before? Anybody heard of a one-shot?
Yeah, I've worked with one-shots.
So how would you describe a one-shot?
The exact way it sounds. It's like if you press the button 5 times, it's only going to shoot it once. That makes sense? Kind of way I do it.
Not quite.
No, maybe it's different. I don't know.
It's a one-shot. Addie, did you want to try? You started to say something? Oh yeah, no doubt.
Yeah, so basically for one shot, it's regardless of how many times the input comes on, it basically looks for the rising edge, and then it uses that rising edge to trigger an output or trigger a certain function after that associated with it. So it's basically looking for the first rising edge and then waits for almost the second rising edge, which comes whenever.
Yeah, so that's the key there. No matter how long an input is on for, it will only execute what's on the other side of the one shot once. So you're using the term rising edge correctly there. So let's say we have examine close, examine, and then a one shot, and then a move. So we'll call this a test. We'll make it a bool. And make that main program. Sure. So, and we'll call this one shot one. The one shot one is a bool. You can bit reference one shots. So if you were going to create a double integer and move and use each individual bit for your one shots, that is also valid. The key with the one shot is it is just a single bit. So we're going to move, we'll call this source. And then we're going to move that into destination. And here, we're going to have one, destination one. Oops. So when we turn this on, it looks like both of these have happened. So it moved 10 into destination 1 and source 50 into destination 2. But because we know that the PLC is constantly scanning, if we go into destination 1 right now and we hit 0, it stays at 0 because it only moves it the very first time the one shot sees that rising edge. The very first scan that this is true, the one shot turns on and then allows the logic behind it to execute a single time, where this branch without the one shot is constantly moving the data into it. We can't overwrite that until this becomes false. Again, we turn this back on, it moves the data into there. So why would this be useful? Well, if we want something to only happen once, if you want to trigger a tee-off timer with a one shot, so you know that something will happen and then turn on and then allow the timer to turn off a device or run without being held high. I see this a lot. We see this a lot with data manipulation. If you're trying to calculate averages, you're trying to calculate mins and maxes, and you only want to capture something when the max happens once, then you can run evaluations. So let's say we only wanted this to happen instead of when test became true. Well, now we can start adding in some logical evaluations. So we'll find those under math and compute and compare. So let's add an equals. So we will have a condition as a dint, a real value, and we'll call this state as a dint. So when condition 1 is met and we're in a specific state, we might want this to execute, but when the condition changes, we don't want it to. So if a value reaches a specific value and we want code to run, we want to clear a timer, we want to clear something once to allow elapsed timers to run, but we don't want to hold on a reset. One issue that I did see in one of the assignments was somebody used a button to reset a whole bunch of timers. Well, the only issue with the implementation of that was that it was a two-state button where if the switch was left in the clear mode and just stayed there, while the timers and the counters would continually be reset. So if a condition were to be that switch to then spam the resets of all of the devices only once, it would prevent an operator from accidentally leaving it on and then stopping your automation equipment from operating, because none of the timers would actually accumulate. Does that make sense? Another thing that I've seen this done with is we were using counters to calculate things that were happening. So the number of times a button was hit. Well, because we can have an equal or we can have it greater than. So now a condition has to be greater than the state. And let's say over here, instead of a moving information, we can actually do an add. And here, let's do the same thing. So we're going to take source 1 of 10. We're going to add 1 to the destination, and we'll take source 2 of 50 and we'll add 2 to the destination. So this could be an example of there are some types of flow meters that don't have analog signals. We've been talking about analog signals, we've been talking about digital signals, and when you're trying to deal with volumes, there's two ways to do that. So you can either do a bunch of math to kind of splice up all of the values of an analog signal and then add them all up and then divide them by the number of samples and the time that you've collected those samples to then be able to calculate the total amount of flow through the flow meter. The math isn't perfect and it's very dependent on the sample rate of the PLC, but there are other flow meters that will work on pulses. So when the flow meter itself calculates that 100 liters has gone by, you'll get 1 pulse, and then you can add 100 liters or whatever to your signal. Maybe that pulse might stay on a while. There could be a latency to it. So instead, let's say, well, we have a condition that becomes true. Well, now we've added 1. Oh, this isn't more. Huh. Normally this will. Oh, I was expecting that to do something else. Interesting. That only fired once. The add. Why isn't that adding? These would normally continue to climb. I wonder if. What did I do? There, sorry. I messed my example up. So if you need to continually accumulate, adding a source, so your source would be the 10 liters that you're adding to your current total. Sorry. Because of my mistake, I may have confused somebody. Does everybody understand what I said, or do you want me to go over that again? Okay. So let's say you have a pulse flow meter. So there's two types of flow meters you've got. One has an analog signal that's 4 to 20. If you need to calculate a total of an analog signal, and I can show you how that math works on another processor. I off the top of my head, I can't remember how to do it. I can show you how I've done it many times. You can use totalizers for it to calculate based on your instantaneous value. You take a whole bunch of snapshots of the instantaneous value, add them up, and then divide them by the number of samples that you have, which will allow you to approximate the total amount of volume that's passed through the device. It's kind of a pain, and it's subject to some variance. That's why there are totalizer add-on instructions built into controllers that try to make the math easier to do. Totalizer up here. Totalizer. Add-on instructions. Predefined total. So you can see these are all of the different parameters or tags used inside the totalizer, to talking about sample rate, sample time, current values, thresholds. It can be complicated. So you can get pulse flow meters that when the flow meter sees has calculated that 50 liters has gone through it, it's easier to trust the instrumentation to calculate that, and then it would send a digital pulse back to you. So instead of using the greater than instruction here, let's go back to our original pulse. And we'll put the test back in here for now. So let's say that we've got the flow meter, and each time that flow meter sends a pulse, it's going to add 10 liters to our total. So our source one is the calibrated value, the pulsed value of our flow meter of 10 liters. So every time we see a pulse, we're going to add 10 to our destination, and we're going to take the destination plus 10, and the second pulse we see will then take our new total, which will be our destination plus 10 again. The one shot allows that pulse to maintain for longer than an individual scan cycle. The one shot allows the pulse to come on, because the pulse, it'll go quick, but did you see how fast, if you could hear my mouse or me just toggling this on and off, that pulse, even though it came in very quick, well, the scan cycle is so fast that it continually adds 10 every scan cycle to your total. So sometimes you need to make sure that something only happens once, because even though something may be on for a very short period of time, that is 220 cycles. 22 cycles? 22 cycles. So in the amount of time that this one only did one, this one calculated 22 tips. So this is an example of when I have used one shots for this type of pulse flow meter calculation. Does it make sense? So then, and then it makes sense about the reset of the push button to reset timers as well. For example, if we can add in counters. Whoops. Whoops. Call the CTU. So we've got a system merrily running away. I think you get it. And right there. And we've got a reset. Well, that reset is a push button and the system's still running away. So now you can see I'm just holding toggle here, and counter 2, it can't accumulate anything because that switch, that button is being held down. But because the one shot prevents that from continually resetting, it allows it to continue going. Does that make sense? Great. This is my preferred way to use one shots. There is another, there's a different syntax that you can use. So you can use one shot risings and one shot falling. So there's an OSR, which is a one shot rising, which is, this is a one shot rising. So the ONS, the inline use of the one shot, is a one shot rising execution of the code. It's just more streamlined. And I have never seen in Logix 5000 anybody use the old way of doing the one shot. But you might encounter this in a different processor, something similar to this, where you actually have an instruction and a storage bit and an output bit. So to kind of explain how the one shot would be working is you have a storage bit, which is internally stores the rung condition in from the last time the instruction was executed. Again, there are various operands addressing modes possible for the data bit for this section. And then the output bit is the output of the instruction. So you can see here, this is another that we've seen this type of time graph of the conditions. So the rung condition in goes high, and you can see here the storage bit goes high and the output bit goes high, and the instruction is then executed again. But the output bit is low. So when it sees the one shot, it runs for a scan. This is trying to indicate that this is the scan interval. So what that would look like in operation would be something similar to this. How would I? Remember how this works. So that's so here's another interesting thing to note. Counters will continue counting past your preset. So even though this is done, it'll still count up, where a timer will stop once it's reached its preset. So when we fire this output, so the OSR output, it operated only once, even though we're holding this high. Again, it's the same thing. So the OSR, so if you see this in a Slick or a MicroLogix, they just haven't, you're just running a firmware or you're running a processor that needs both of the bits kind of addressed specifically. And if you had an OS F is a one shot falling. So remember, rising edge, leading edge is when your system becomes true. When you see a 0 to 1, a falling edge, if you watch our reset here, and I drop this counter. Oh, where did that fucking reset? OSF storage bit. Oh. That is annoying. So even though so again, when we fall, it resets. So that so it's true. And then this is if it's kind of the same idea of timer on, timer off. We've got a one-shot rising. We want something to happen only once when something turns on. If we need something to happen when a condition turns off, we would use a one-shot falling. And then when that turns off, the output bit becomes true for a single scan and the counter reset. So I've never used a one-shot falling. I would program it in such a way that I would instead use like a normally closed contact of something being true to then trigger an ONS. The ONS is easier. It uses half the amount of memory because it builds its own storage and output bit based on the single bool. Any questions on one shots? Great. All right. Let's get on to some fun math. All right, fun. All right, so I've already showed you guys one of the math functions that we've got, but there's a bunch of them. So we have add, subtract, multiply, and divide. All your normal bits are normal. What would those be called? Functions. If you ever need to add something, pretty straightforward. It takes A plus B equals the destination. So you can either add dints, 1 plus 2 equals a destination. So we'll go math. Zero. Zero. Let's do that instead. 1, 2. So here's an interesting one that some people don't love. These will all execute in 5,000 like this. So if we take So you'll notice as soon as I added in that last data bit, that tag, this became valid. So I can assemble this. Does anybody know why I did that?
I can't divide by 0. Probably get an error of some sort.
Yeah, it will do that. So this processor is now very unhappy with us because there's an arithmetic problem. We're dividing by 0. So every other processor I worked with, that would fault the processor. So if you divide by 0, you divide by something, it will be angry. So, but you can see here, 1 plus 2 is 3. 5 minus 1 is 4. 5 times 3 is 15. We'll go 100 divided by 6.45, and we'll spit it out. Pretty straightforward, right, guys? So let's say now I've put tags in here, so you can also hard code something in. So let's say you're always going to be adding 5 points, whatever here. You can do that too. So whatever this value is, plus 5.678. If you have a constant offset for some signal, you can hard code. You can add and subtract real values, integers, double integers. The only thing is, if we were taking this signal into an integer, it's going to truncate the decimal places. Integers do not have decimal places. So be wary of that if you require to keep your decimal places. You can do some funny things with math if you need to do, if you need to put things into integers. Like, let's say you're working with, if you're working with slicks and you need to transmit data to them, or you're working with another type of processor that only works in integers, you can convert things, but again, you're potentially going to lose data resolution. So the next compute function is actually the compute function. So CPT is, we're going to move CPT into 25. So in this expression box, you'll notice that it opened up differently. This is where you can do a bunch of different math. So you can add in tags. So let's say I've got, were they all local? Oh my goodness, those are all local tags. State. Yeah. Tag 1, 2, 3, and I want it times 6.67 to the power of 3. I think that's the syntax for that. Yeah. No, it doesn't like that syntax. Double. Yeah. That value is 0. So we'll skip back here. I did a different tag. Sorry. 12. So that is 12 times 6.12 times 6.67, and then scientific to, oh my goodness, 6.67. 12 times 6.67. Why can't I do that? To the power of 3. Is that right? Yeah, that's right. So you can type in a number of things instead of having to chain together a whole bunch of math. So if you needed to do this plus that, subtract that, you wouldn't necessarily need to add and then create a destination for it, and then take this destination into a multiply, and then take that and then divide it by 100 to get a percentage. You can put far more complex expressions in here. The only thing is the syntax in here is a little funny. It's not the same as Python. It's not the same as some other programming languages. But all of the operands are in here. You can do trig. So there's arc, sine, and you name it. You can do a bunch. Greater than, equal to. You can put those in there. I think they might support if statements now. Format, maybe not. Ands, ors, XOR. So you can do a lot of pretty wild math inside those compute blocks. If you need to, you're calculating the mode of that, why you would need to do that. It truncates the floating point of a value 2 to the power of 2 and divides the truncated float by that result, then stores the remainder. Great. There's a lot you can do with the compute function if you need to. Obviously you can see the world is your oyster with that one. Any questions about compute? Perfect. Sorry, I'm just reviewing some of the notes and the reading material. So for comparison, this is how we can output. So these are all outputs of systems. In a slick, for example, you couldn't chain these together like that. You would have to OR them up. So you would have to do something like this for this to be acceptable. You couldn't put those in a row. Some people don't like the practice of leaving them in a row, even though it runs in the 5,000. I'm indifferent, to be perfectly honest. But if you're looking at these type of instructions inside of a slick, let's see. A flow meter. We will have, so here we've got a divide. If we were to add in another one, even if it's the same one here, and we were to try to build that, it won't let you, because there are two series outputs. So you could parallel them up like they've done here. So if this registers in state 0, you're accumulating flow, and then here's the here's that period that I was talking about. So there's a value that you're adding to your total. So add A plus B into a destination. So there's no one shot being used here, but it's actually using the internal clock of the processor to take an instantaneous value, take this value and add it every second. So this value, every second that the device is running, is accumulating 0.01 liters. And then depending on where the flow is being directed, it's being added up. So instead of using the one shot for a pulse, this is actually an analog value that's being conditioned and then sliced up into tiny little pieces. And then the assumption is then that all those pieces are the same size. And then you count up the number of pieces that you've cut out. This is kind of an older school way of calculating flow totals. And here's another interesting math. So here, this SCP is called a scale with parameters. Now, this is a function that was built into the Slick 500 library, and it will take an input of an integer or a real value, and it will scale it between 2 points. So you'll take your input min and max. So right now this is for the analog input card. So last week when we were talking about taking the analog input value as engineering units. So if we take, for this particular card, it comes in as raw counts. And it's been determined that this is equal to 4 milliamps, and this value is equal to 20 milliamps on this particular card. So what this instruction does is we'll take that input value and scale it linearly between these points and then 0 to 100. So for this one, it will scale the analog signal between 0 and 100%, or 100 liters per second for flow. And it will do that math within this instruction. Does that make sense? This is a very useful function that doesn't, at least unless they've changed it, never existed in 5000. This is an interesting one that I've programmed a couple of times. Yeah, they don't seem to have a scale. Oh, there's a scale. Oh, look, they added it in. Scale? No. Okay. What? How do you call that? How do you call that? Interesting. Doesn't look like there's an add-on instruction for it, but there is a data for it. Why would they do that? Sequencer. So I've just not used this. This is version 30. I just haven't used this version of the software in my professional career very often, obviously, because they are adding new features and instructions. Where the heck would that be? That bothers me. There. I'm gonna look that up. And let's go to message permits. There's something else I want to show you. CD here, compute. No, or yeah. So here you can see this is what the compute would look like inside a 5000. You don't have tags, so you would actually have to look at this, write this out on paper, and then start looking through your data files. So you'd go to 244, find 244.3, take a look at it. It's CT calc volume. 244.4 is CT calc duration or discharge flow rate. So you're looking at discharge flow rate times 60 volume divided by the flow rate times 60 divided by 1000 times a baffling factor times the chlorine residual. So for the slick, it's a little more work to try to figure out kind of what's going on in here. But if you're doing proper rung descriptions, you can write all of this out and you don't have to dig around and find that information because it's right there. Other than that, all the instructions that we've kind of looked at are pretty much the same. And bit. So here we do have a so this, at least this version of Logix 500 does have, this is the OSR. It doesn't look like I have an ONS. No. So it only, so this one only has the one shot rising, and it looks like it stores the whole thing in a single bit address. Oops. No, you're not gonna work for me. F1. One shot rising. Input that triggers an event to occur one time, use one shot rising. When the event must start based on the change of state of the rung. An example would be to use OSR to freeze rapidly displayed LED values. So this exists, and then it is compatible with SLIX 502, 3, 4, 5 MicroLogics. Looks like they fixed an issue for SLIC 501. So again, another, always look at your help files if something's not working properly. So I was showing you earlier about a couple, I used the greater than. So you can, so these multiplication, all of these math computes, these are outputs. They will move something, they will output a value in some way. Same with the timers. So your input conditions, your compare conditions, we've got a couple of them. So equals, not equals. So EQU, NEQ, LES. So we've got equals. That's pretty straightforward. So it will be valid. So if you imagine this like a gate or even a bit, like if source A and source B are equal, then logic will pass through. If they are not equal for an NEQ, then logic will pass through. When using equals, I do not recommend using real values because real values can go down to 50 or 60 decimal places. So they have to be exactly equal or they are not valid when using these. So stick to integers and double integers where it's whole numbers only to save yourself a headache. So with less than and greater than, it's exactly that. So A is less than B, then it is true. So this will execute code to the right of it, and greater than, if A is greater than B, code will execute to the right of it. Any questions about these? Do you want to see them working? I was going to show you some of the next ones, but I can show you these ones if you would like. Pretty straightforward. Great. So a little bit of a twist. So we have go with All right. So LEQ and GEQ look very similar to LES and GRT. They're slightly different. So they're greater than or equal to. So exactly as it says here, if A is greater than or equal to or less than or equal to 5. So if we bring this up to 20, output becomes true. If we go to 11, it's also true. But if we go to 10 point, oh, 2, I got greedy. Ooh, did you round up? At some point, it rounded up. Interesting. I changed the way that works. 9 point. Yeah, so. Notice how I just did a very, very small number to see if it changed anything, but you can write, sometimes you will see a return in scientific notation for very small numbers. And then greater than or equal to, but 50.000. It rounded down. It's like they fixed that. But again, if your resolution, it can be problematic if you're looking for it to be exactly 50. You might have issues with these things working with live values from instruments. Any questions on less than or equal to and greater than or equal to? Good night. That was Maggie. Excuse me. So the last most common compare that you're going to run into, excuse me, the limit. So you can see here, oh, we'll do math. What do I got going on? Math. There. Oh, I don't like how I did this. There. So if you have to use real values, limits might work better for you. So instead of just being greater than or less than something, a limit will allow you to work within a specific range. So let's say the time is 3:14 and you want something to be true between 1 o'clock and 2200. That's a valid, that's valid. So because 1415 is greater than the low limit, but less than the high limit, the output is true. But if it were 8 in the morning, it is not true. If it were pressure range, so let's say you've got a kettle system at 800 that needs to be on between 800 and 900 kPa, or does not, or yeah, needs to be on or is safe between these values. Well, our low limit, so this is lower than or equal to, you can see that there. So it's, if I'm 900, I'm good, but if I'm 901, I'm not good. So we're in the green. We are not in the green. If you need to evaluate higher, you can have multiple limits. I believe you can have multiple limits in the same rung. Not super great. But you can have limits. You'd obviously want them to be different values. So let's say you wanted it to be, it has to be greater than 800 and less than 900 for the pressure. And there's another kettle that has to be greater than or equal to with pressure. You could series these up. I would probably not do it that way. If for the example of monitoring temperatures in kettles, I would likely do it more like this and add in additional bits to monitor each one of the kettles are good. But you can use these signals as temperature okay, pressure okay, whatever signals level. If you need something to happen between values, you can set this up as an accumulator. You can have these as accumulators to count parts, have things happen with so many parts, have cycled through a system. I've even seen some HMI systems like touch screens for assembly lines have people log in, entering in a code, and they'll use a limit inside the logic that if somebody's code falls between a certain range, they're an administrator, and it allows them to change set points. Not the greatest. There are better ways to do security, but there's lots of things that you can do. If you can associate anything with a number, you can evaluate it. You can do more math to it. Yeah, that's the last common instruction that we have really to cover for today. And by no means are these the extent of all of them. They're just the ones that I've seen the most and are even are in the reading material. So the reading material goes through a lot of these as well if you want to read through that. Compare expression. So this compare expression, you can write more advanced comparisons. So if you wanted to do advanced math and set limits up, do greater than or equal to it, you can do some pretty neat things inside the compare, and it just has a different syntax than setting up specific limits. And again, you can chain them through. I've never I've never needed to do anything in the compare that wasn't available as its own instruction, but you might come across some fancy machine that you have to do some fancy math. I also I've never used this mask. Well, that's kind of neat. I don't know what that would be used for, but it uses it looks like they're using a bit mask here to compare two sources. So you could use this to compare, I don't know, if two, I remember how we were looking at, IP addresses, or maybe that, yeah, everyone here is in the other program where we were converting the IP addresses, the last octet in from digital to binary, and then also converting the mask, the subnet mask. It looks like this is doing a similar task by comparing something against the mask. You would then have to, I believe, compare it a second time to evaluate compatibility between multiple signals. I've never used this. So I don't know. I don't have a real world example as what it would be used for. For math, there's a few other ones that I have used. I've used absolute value sometimes. Absolute value is just taking, if you have any number, whether it's negative or positive, and it essentially just makes it positive regardless of what, whether it is negative or positive. I've done this for calculating specific deviations, whether you're high or low. Sometimes you don't want to use the negative value. You can also do square root, which is exactly that. If you take math into oops. The square root of 900 is 30. Negative will make a positive value negative. Instead of having to multiply it by -1. Yeah. That's the end of my lecture for the day. If you guys have come across any other funky stuff that you want to ask about, by all means ask. We can talk about it. If I've seen it, I can look them up as well to try to find some other examples of them being used. But again, I highly recommend, if you need to, use the hit F1 and use the search, like the help menu. It's invaluable. I use it not every single time I program, but a lot. Yeah, so if there aren't any other questions.
Actually, Ryan,
Yeah.
in the RS5000 program, is there a hotkey to pull up all of the like bit functions like there is in RS500?
like
Like in RS500, you hit Alt, I think it's Alt 4, and it brings up like a little box that has like remove bits, timers, one shots, and all that.
there is?
Yeah,
Goodness. Oh, ha! My
yeah,
God, I've never done that.
yeah. It makes it a little bit easier some days, but I
Yes.
wasn't sure if the 5000 had that.
Blew my. Now I'm just doing alt and buttons, man. Instruction palette. Okay, well let's see. Let us learn together. So I hit Alt 4 and it's like cycling, it's like closing windows. It's
Okay, so a bit different on this one then.
yeah. So okay, so here's something that you might want to do. So I programmed primarily, I started with Logix 500 and I really enjoy the like different colors here. I like it. I find this is easier to read. The color itself, I could give or take, but being able to see rung descriptions, I like. So let's say we've got this, and I'll add in run comments. Like here is a run comment, and I don't know how to use cap locks. Another one. More rung comments. Go here. So we go to tools, options, and then ladder editor display, or font and color. So we've got a bunch of so these are all the different items that you can see on the screen. But if we go down here and go to run comments, we can actually add in color, hit apply, and now our run comments are off the screen, and oh my God, and now those are different. You can do the same thing with descriptions. So let's say it's just to mimic the descriptions are yellow. And then what was the other one? It was like tag alias information. And background blue. Oh no, we don't have alias information. Sorry. What are drop zone indicators? Are the little dots that you would get. Where is the is it that? No. I was trying to find the tag information. What is that called? Power flow, that's over here. If you don't like green, you can make that red. There's another, there are other softwares where that's red and people like it. I don't. Red, danger, red. I just don't like it. But you can organize it however you want. You can do the same thing for your function block diagram, sequential function chart, and your structured text. You can change all of that if you want. It does not affect anything really. It's just really, it's just up to you. You also have a bunch of additional toolbars if you want to open them up. So custom tools, they'll just open up here. We can open a whole bunch if you want. So this I know was a Slick thing. So there's a lot of the standard ones that's right out of the Slick bar. Come on. One of those buttons that I hit got rid of. That's this. That just copied it. So it was Alt-4. What was it called? Alt-4 instruction palette. Failed to launch control flash. Oh. No, I don't see an instruction palette. You can add this would be adding new programs, trends, instead of doing it over here to add a new task or trends. You could force them. Are some of these useful? Sure. Are they? Does it really matter? Yeah, you'd probably want to keep your language bar. This path right here, this is just specifically going to be the path for your processor. So you can set it when you go who active. You can, if you navigate to this one, you can actually set a project path, and now it's embedded in your code. So you don't have to navigate. And next time you go to who's active for this controller, it's going to go right to that path. The caveat with that is that if you have multiple people who might have set up their RS links differently and they're not named exactly the same thing, that's just going to not work. The next time one person opens the code, it will change. So if it's only you or one specific computer, save yourself 20 seconds of trying to find stuff all the time. That's really it. Let's see. We'll call it the instruction palette. Logics. It doesn't look like that's a thing in Logix 5000. Sorry. But that is a kind of, here's a neat document. There. I just dropped the neat document that has a lot of information. This looks like it's a lot of the help file, to be honest. If you want to read something that will help you go to sleep, go for it. Yeah, sorry, I'm not seeing a shortcut for.
Ryan,
Hi.
could you try clicking on a rung that you can edit and pressing the insert key? Yeah, so it does work.
There you go. So that page up and page down. Yeah, sorry. I don't really want to have you guys watch me struggle through trying to find some of these little hotkeys that I've just never
Little
used
tricks.
myself. Yeah, like you can Google this stuff yourself too. You taught me something. You might save me minutes on the rest of my life. Thank you. Yeah, that insert's pretty cool. Like there are so many different, you want to convert radians to degrees, go for it. There's that truncate, which would just be drop so many digits off of a value. Motion configuration, I haven't touched motion since I went to college, so I would have to look up anything motion wise. Again, we're only scratching the surface on a lot of this stuff. Yeah, you'll master the stuff that you use all the time, and then you'll slowly be able to pull from the rest of the tools as need be. So yeah, if there are any more questions, shoot them out. If not, that's the end of my lecture for the day, guys. There is a quiz for this week. There's a challenge quiz, but there's no lab material. There's some reading material to go through. I covered as much of it as I could as demonstrations. So I'm going to stop the recording. And yeah, ask away. If not, have a good night.